Okay, so we shall write down the circuit diagram for this particular expression. So before writing the circuit diagram for this, we shall bring the equations in another format. So why I have to bring these equations into another format is, so these two expressions are small, but if you compare this and this, see how large it is. If the expression is very large, your circuit diagram will also be very large. So therefore, how to simplify my circuit diagram? So if I want to simplify my circuit diagram, first I have to reframe this equation. How to reframe this equation? Okay, let me not touch B3 and B2. Okay, let me not touch that. Now I can write B1 as, so B1 is equals to G3 XOR G2 XOR G1, right? G1, right? So we know that G3 XOR G2 is nothing but what? G3 XOR G2 is nothing but what? From the whole equation it is just B2. So B2 XOR G1. This is B1. So let us consider this equation. So let us implement this equation. Okay, instead of this, let us implement this equation. Okay, how to reframe this equation? Okay, so what is B0? B0 is equals to G3 XOR G2 XOR G1 XOR G0. This is the expression you have got. But what is G3 XOR G2 XOR G1? It is nothing but B1, right? It is nothing but B1. So therefore, instead of this, I will write it as B1 XOR G0. This is equals to B. Okay. So let me use this equation instead of this. Instead of this equation, let me use this. So therefore, your circuit diagram will be small. Okay. So what is the first equation? What is the first circuit? So towards the left side, you should be using B3. Towards the right side is G3. This is the first circuit diagram. So there is no gates that you are using. You are just passing one particular wire. Whatever the value is there in B3, the same thing will be observing in the output as well. That is G3. So now how to write down the B2? B2 is nothing but G3, G2, no? So what is G3, G2? What is G3, G2? What is G3 XOR G2? So I'm telling about B2 is equals to G3 XOR G2, no? So what is just G3, G2 bar plus G2, G3 bar? Okay. So by using this equation, I write down 1. So here towards the left side you have to write, towards the left side what you have to write, towards the left side whatever, so this expression is G3 G2 bar plus G2 G3 bar, no? So G3, let me write G3, here also G3, here you will be getting D3. We are converting the gray code to binary. See here, gray code to binary. So towards the left side G3 will be there, and towards the right side B3 will be there. Okay, so G3 G2 bar, okay, and G2 G3 bar. So G3, this is G2, G3 G2 bar 1 and 8. Okay, one more is G3 now do, next one more not 8. Here you have to use one more or 8. This is what? This is D2. So let me write down the another circuit. Let me write down for B1, that is B2 and G1, that is B2 and G1. This is what? B1. Okay, so let me write down for B0. B0 is equal to B1 and G0, XOR of both. So B1 and G0. This is B0. So now let me write down so these are the only 4 circuit diagrams you have to implement. So if you want to implement this circuit diagram, you cannot implement each and every circuit separately. All the circuits you have to implement at a time. Okay, whenever I am explaining about the practicals, then you will understand. So let me write down the pin numbers. So how many NOT gates are there? 1, 2, 3, 4, 5, 6 NOT gates are there. Anyway, we will be using only one IC because in one IC of NOT gate there are 6 NOT gates. So 1, okay, let me use a different chart. 1, 2, 3, 4, 5, 6. 7 we should not use. 8, 9, 10, 11, 12 and 13. Okay. Coming to the AND gate. Coming to AND gate. How many AND gates are there? 1, 2, 3, 4, 5, 6. 6 AND gates are there. So how many ICs you want of AND gate? You want 2 because in one IC only 4 AND gates are available. So 1, 2, 3, 4, 5, 6. 7 we are not using. 8, 9, 10, 11, 12 and 13. So this is all, this much AND gates you are using from first IC. So again I am using the second IC means you should again start it from the 1. So 1, 2, 3, 4, 5, 6. And now how many OR gates are there? 3 OR gates are there. So therefore 1, 2, 3, 4, 5, 6, 7 we are not using, 8, 9 and 10. So this is what the pin configuration for all the circuit diagram shown. Okay, don't be confused with the expression, just make a note properly, you will never go wrong. Okay, fine. So now in the exam, that is in the Viva, they may ask you to write down the binary equivalent of, okay, write down the binary equivalent of a gray number 5. So this is a gray number, they ask you, the gray number is 5, okay, write the binary equivalent of gray number 5 means what you will do, what you have to do. So this is a 5 is a gray number, now you have to write D3, okay, D2, D1 and D0. Okay, so now, okay, let me explain that application part a little bit later. So right now you copy down all these things. Application part I will explain a little bit later.